how we roll there. Some rock, some win, some 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 win.
Well. Welcome back to Zig Showtime. Kept you waiting, huh? So it's been a while since the last Zig Showtime episode aired. So I want, first of all, to thank everybody who has been a long-time viewer of Zig Showtime, but also I want to welcome newcomers. So, and to give them like a little bit of an idea of what Zig Showtime is about. Zig Showtime was born during the pandemic lockdowns, and it had three main goals. The first goal was, so in order of importance. So goal number one was to keep us entertained, to allow interesting, to let the community know about interesting projects and ideas. The second goal was something for myself. It was to give myself some experience when it comes to hosting a show, producing it, organizing stuff. And with the idea that with the goal of eventually translating that experience to in-person events. Since then, we've had at least we had a couple in-person events. Like we had also meetups, but we had also two big conferences, Software You Can Love. One in Milan last year, and one in Vancouver this year. Also Vancouver in Canada. So also thanks Matt Knight, who's in chat, for being the main organizer of the second event. And at the same time, as we speak, I'm working on announcing the third Software You Can Love, which is going to be next year in May, and it's going to be back in Milan. So overall, when it comes to the second goal, I'm very happy. I feel like I've really, achieved what I wanted to achieve. Of course, I'm not a perfect host, but still, I'm happy with where I am. So I would say that the second goal is fulfilled, which leaves more space to the third goal of Zig Showtime, which I guess you could say it has now become the second goal, which is to give the same opportunity that I carved for myself with Zig Showtime, to give that also to other members of the Zig community. So to have a space where people can come on the show and give a talk, even if it's their first time giving a talk in front of an audience ever. So with the idea of ideally, eventually being able to give better and better talks, maybe at in-person events. So if you're interested in our journey and you want to follow us, here's a couple of things that you can do. Go to the official website, zig.show, sign up for the newsletter so you can get notified when a new episode airs. Join the Discord server so you can hang out with us. And last but not least, consider checking out the call for speakers so that you too can take advantage of this opportunity and come on the show and tell something interesting to the Zig community. So before we move to the main event, just one last thing. Please, Mitchell has a chat feed open somewhere on his table, and so he can see chat. And it would be nice if we, once I'm done announcing his talk and he comes on air, it would be nice if we gave him a warm welcome. So I expect a lot of clap emojis in chat and a bunch of spam. So thank you. So I guess it's time to get started. Mitchell probably doesn't need an introduction as he's a public personality at this point, but he's also been a very good member of the Zig community since he first started hanging out with us. He's been active in discussions, has participated in the development process of Zig, and he also has written some very informative blog posts on Zig internals. On top of that, I also have some personal thanks to give him, because of his NixOS VM setup on Apple Silicon fits me like a glove. So thank you, Mitchell, for that as well. His talk today is about Ghostty, a new terminal emulator written in Zig, and I know what you're all thinking. Yes, it does run Borg. You shouldn't expect me to say anything different, but today I'm genuinely thrilled to have Mitchell on the show. So, without further ado, please chat, give a warm welcome to Mitchell Hashimoto.
Hello everyone. Super excited to be here. Sorry for the delay. I think a lot of you know, but I had my first child born last week. She came early, unexpected, but yeah, born the day before Zig Showtime was supposed to be on. Uh, that's why we had to postpone it, but sort of getting in a little bit of a groove now, so I didn't want people to wait too long. So I'm really excited to give this talk. And yeah, let's get started. So as Laura said, I'm gonna be talking about Ghostty. Ghostty is a terminal emulator written in Zig from scratch. I've been introduced, but here's 5 random pictures of me eating these. I'm not a foodie or anything. I just wanted there to be some sort of thematic element, and I found a picture of me eating, so I decided to make all of them of me eating. Yeah, I've started some popular software projects in the past. You may have heard of them, you may have not. There's projects like Vagrant, Terraform, Vault, etc. Um, just so you know, I haven't worked on any of those projects in many years. I think most recently, like I maybe worked on Terraform 5 or 6 years ago, but it's really been a long time. But I did help start them maybe a decade ago or so. Um, I'm also one of those people that has always had a side project going on. Always, like even when I was in the thick of sort of the work I was doing over the past decade. But like for example, around 10 years ago, I wrote a Hearthstone, like the card game, log analyzer and replay software, and I was able to sell that actually to a pro esports team, and they used that to run caster views for their tournaments, which is pretty cool. I also wrote my own mail server from scratch a few years ago that I never open sourced, but I do actually use that from scratch mail server on some of my domains to receive. And now I guess I have a terminal emulator. Yeah. Okay, so this is about Ghosty, the terminal emulator. And before we get started on anything, I just wanted to show you what it looks like. So here's a screenshot. I took it a couple weeks ago. And just in the screenshot alone, you could hopefully see that it's pretty full featured. Just looking at this screenshot, you could see that the native experience looks pretty good. Supports true color, runs Vim just fine, has multiple font styles. You can see bold and italics and regular here. Also, you can see it has the Kitty graphics protocol, which works fine. Yeah, I think that's everything in this screenshot, but it does a lot more than that. So here's just, here's the thing. Okay, but terminal emulators, right? So I think everyone here probably knows what a terminal emulator is. Maybe some people here are a little fuzzy on the boundary between a terminal emulator and a shell and a running program, or why a terminal emulator has the word emulator in it. All that's sort of fine. But the software of a terminal emulator, here's a good list of terminal emulators. So GNOME, XFCE, Kitty, Alacrity, et cetera, et cetera. You probably use one of these, and there are dozens and dozens more, probably over 100 more terminal emulators. And so if there are so many terminal emulators, why did I make another one? That's like the question I want to start out with here. That's usually the question people have when I say I'm working on a terminal emulator. It's like, why? I thought they're done, right? Um, so so this is sort of the first reason that I came into it. There's a lot of reasons, but this is sort of the first reason I came into it. Sort of at a fundamental level, this is the state of terminal emulators as I saw it, my opinion here. I think this is still accurate, but this is as I saw it a couple years ago. I've been working on Ghosty for a couple years now. It feels like you have fast terminal emulators, you have feature-rich terminal emulators, and then you have sort of native experiences that I split across Mac and Linux. There's Windows too, but just for the sake of making this chart readable, I just did Mac and Linux. And in this sort of table, a green check mark means it's sort of like, good, not best in class, but in the group of best in class sort of options. And I'll explain the warning signs in a bit. But what I felt a couple of years ago was that it was almost like a you pick two sort of situation. And so if we look at what I'm trying to do with Ghosty, it's obviously aiming to do this. In my opinion, I actually already achieve or deserve the green check marks in all of these columns. But regardless, this is also the goal of Ghosty. So I don't think this has to be a mutually exclusive choice. I think you could have all of this without sacrificing anything. And so if you look at Alacrity, it's super fast. That's how they advertise themselves from the beginning. That speed in some ways came at the cost of features. That's not strictly necessary, but they've been very, very strict at all times about being lighter and lighter on features if they impact speed in any way. So I think the biggest, most popular issue example on the Alacrity issue tracker that I remember is ligature support. They pretty much refuse to add ligatures in an official way. The reasoning given multiple times is that it makes things a little bit slower, which is true. Doing something costs more than doing nothing. So doing ligatures obviously costs more than not doing them. But ligatures, a lot of people love them. So even if it's making things microseconds slower, I think you should have features like that. You could always turn them off. So that's an example of Alacrity. Kitty is fast. It's certainly not as fast as Alacrity in some benchmarks. It's faster in other benchmarks, but it's fast. It deserves a green check mark. And Kitty has a lot of features. But here's where I start having sort of the yellow warning signs across Alacrity and Kitty. And the reason I do that is they work on Mac and Linux, but I don't think anyone would call them native, right? Like if you look at Kitty tabs, Alacrity doesn't support tabs. Alacrity, if you launch a new window, actually launches another process, which makes things really weird on Mac. Kitty, when you do tabs, they're not native tabs. They're sort of like Vim-like text-based tabs, and it's sort of rendering screen, etc. Like things like that. And so I don't really consider it native. iTerm, sort of crazy slow, but also a crazy amount of features, and of course, extremely, extremely native on Mac OS. Like everything in there is super native, feels great. And so this is sort of the layout that I see it, and I'm going to explain how Ghostty checks these boxes in a second. So sort of at the foundational level, I wanted, the speed of Alacrity, the feature richness of Kitty, and the native look and feel of iTerm on Mac OS, but also analogously on Linux, comparing to an iTerm option on Linux. I wanted it to really feel like it was made for that platform. So that's the goal. There's also like a future look on my goals with a terminal. I think that terminals need to evolve a bit to become a much more modern platform for text application development. I think the analogy I like to use here is browsers for graphical development, for better or worse. Browsers ship dozens or hundreds of new features per year. There are really big cons to that. It's annoying in a lot of ways, but at the same time, applications are innovating super fast, and it does excite a lot of developers. And so, it may be a bit much. I'm not trying to sort of innovate as quickly as a browser. There's also a huge ecosystem around that. But, I think if terminals shipped like 1 or 2 new features a year, it'd be pretty good. So, yeah, I think that there is room for innovation. And I listed some examples of stuff that I'm thinking about that I'd like to add. Let me see. I think is everything frozen?
Mitchell, I think we lost connection to Twitch momentarily.
Okay.
I think it's like what you said for this slide. Like the recording is fine, but if you don't mind, like repeating the last 60 seconds.
Yep. Is it back now? We're back.
Yeah, we're back.
Okay. Did it freeze for that entire slide?
Yes.
Okay. Well, I will explain. Okay, so hopefully the video catches up, but what I sort of ended on saying was that I explained the foundational reasons for another terminal. I think at a base level, if you have speed, feature richness, native integration, you already have enough reasons for a new terminal, and that's my goal. This new slide, which hopefully pops up on the video soon, is looking at the future. I think there's also room to make terminals a modern platform for text application development. And I think the analogy I like to use here the most is browsers. Browsers are a modern platform for graphical application development for better and worse. I am someone who definitely really dislikes everything being Electron, but I also am someone who openly admits that writing for the web technologies is a really, really easy way to develop a graphical application. But at the same time, text applications are pretty awesome, and they're awesome in the right context. But I think terminals have been lagging. So browsers ship dozens or hundreds of new features per year. They innovate fast, they excite developers, and dozens or hundreds of features per year may be a bit much. I'm also someone who is annoyed that every time I come back to web application development, I feel like I have no idea what's going on because everything changed. But look, if terminal shipped 1, 2, 3 new features a year, I think that wouldn't be a bad thing. And so here's some examples of kind of what I'm thinking. Progress bars. Why are we redrawing?
Yeah, sorry, Mitchell. Just to double check, you're still in the Why Another Terminal tab slide, right? Or did you move
Yeah,
forward?
but it says the future underneath it, not the foundation.
Oh, interesting. Well, let's see. Thank you, Discord.
Yeah. Let me know when you're good.
It still says the future on my end.
The future is good. That's what it's supposed to say, the future.
Oh, okay. So it's fine. Sorry for the interruption.
Good. Cool. I can see chat, but I can't actually see the Twitch stream. So yeah, I'll just base off chat. But yeah, so progress bars, why are we redrawing progress bars every single time? And most of the time poorly, especially if you're doing multi-line progress bars. Do you want a percentage on your progress bar? Do you want it to just be a bar? Why is this not a native thing at this point? Drag and drop. I have a friend who uses Vim in a dedicated graphical interface, not in the terminal, and he's in the beta, and he's someone that I really want. Success for me is he would switch from the graphical interface to using a terminal. And one of the reasons he mentioned was that when he drags a file into Vim in the terminal, it just pastes the file path. That's what it does in Kitty. That's what it does in iTerm. We need a way for terminal applications to register for drop events, so they could actually do things like open files. Tab and split control, so multiplexers can sort of use native features. Mouse gestures. So terminal UIs for decades have been able to respond to scroll and listen to any mouse button and things like that. You could right click in NeoVim and get a right click menu, for example. But mice have come a really long way in the past 2 decades. So I think we need to extend those protocols to support swipes and multi-touch and things like that. Improve security. I'm not going to talk about this at all in this talk because it's a whole thing. There was actually 2 good DEF CON talks on why terminals are horrendously insecure, sort of pretty fundamentally right now. So that's something I have some ideas about, but that's just a few ideas. And I think these are solid improvements that we can make to terminals. Okay, so did this change? Are you seeing a new slide that says, is it fast at the top? I just want to make sure all this
it's working.
Cool. Okay, so is Ghostty fast? How do we know? I put that green check mark there, and there's a lot of ways to benchmark a terminal emulator, and I don't want to dedicate this talk to that. The point I want to make in this slide is that it's fast. I'm not going to say it's the fastest. I just want to make the point that if you looked at it in a group of terminals, it would be in the fast group of terminals. So here I show sort of Ghostty running this Doom fire animation. I like using this example because it actually is scrolling to be able to do this. I'm sure it's not coming through full FPS on Twitch, but you could see in the bottom, there's an FPS counter and it's sitting around 490, 480 to 500 frames per second. It's a good stress test. If you try it with some other terminals, it doesn't work as well. And I will link this another time. So you could run this in your own terminal. But for example, if I run this in iTerm, not trying to poke fun at iTerm, just giving actually I'll use terminal.app, official Mac app. No one will get annoyed if I pick on them. If you run this in terminal app, you get around 10 frames per second. Here you get 500. So pretty big difference. If you run this in Alacrity or Kitty, you get around the same amount. You get around 450 to 500. So again, I'm not trying to claim Ghosty's the fastest, but it's in the class of fast. terminals. Is it feature rich? Do I get a green check mark in the feature box? Here's sort of a list of features that are somewhat less common. Some of them somewhat less common. It could run Vim. Obviously, I hope any terminal can run Vim, so it could run Vim. But I also support multi-window, tabs, splits. That's something Kitty and Alacrity both don't support, for example. I support the Kitty graphics protocol, Kitty keyboard protocol, other older protocols. I support variable fonts. So if you actually have a font that you don't just say italic or something, you could actually say the weight is 250. You could actually control any variable font axis. I support ligatures, emoji, all sorts of stuff. So I think there's certainly some things here that are rare. So the combination of supporting Kitty keyboard, Kitty graphics, and for example, variable fonts, I think no terminal in existence supports all three of those. But the point being is that I get the check mark on feature rich, I believe. Here's another way to see it. Hopefully Twitch doesn't eat this up too much. Not Curses demo does some crazy stuff. And so this frame rate's bad, but like that's rendering a real image on there. That's not using like the not curses and this thing fading. And these are real images using the Kitty graphics protocol. And in a second, this whole demo is crazy. I'm not going to show the whole thing, but it's a good demo just to show all the features it supports. I don't like using this demo as a way to do any benchmark or show how performant something is, because not curses is actually pretty amazing at falling back to alternate technologies if it detects they aren't supported. And so this demo actually even worked great in Apple's terminal app, which is a little bit mind-blowing. So yeah, I'm not going to run this whole thing. It's very long, but it's very cool. And is it native? I'm going to show this sort of through, I'm going to tab over at some point and actually show this, but you'll see that it's native. Another way to benchmark that it's native is that, yes, it's written in Zig. I'll sort of cover this in a bit, but 95% of lines of code are in Zig, but 5% are Swift. And that's for Mac. That is sort of necessary to get that native experience on Mac. It is actually a real native written in Swift using AppKit app for Mac. And for Linux, I use GTK, which is all still Zig, since I could interact with C. Okay, let's see here. I think my Twitch stream kind of froze, so I just want, or my local comment stream, so I just want to see if I could get that back. Okay, I think I'm back. Cool. Okay, real quick overview. This is like a ridiculous amount of text, but just a real quick overview of the tech stack and the project itself. So let's start actually with the project on the right side. The project is currently closed beta with source access. So about 40 testers today have access to the GitHub repo. The reason I'm doing a closed beta is because this is a personal project and I don't want to overwhelm myself with issues and sort of the problems of the world. So I'm doing it slowly. Like I said, I just have a week-old baby at home, so my time to manage things is more limited. So a closed beta lets me sort of slowly invite people, fix their issues, and repeat. I'll probably expand that pretty soon. We're at a pretty stable point right now. The project will be free and open source. We're looking at it's most likely the GPL license. The only reason I say most likely is that testers are open to share their opinion, and we still have time to make that change, but the plan is probably GPL. There is a public Discord with the link here. I source the beta testers from that Discord, so if you are interested, join that. And there's a devlog where I write about sort of changes and the complexities of terminals. And on the left side of tech stack, I'm going to go over a lot of this in this talk, so I won't spend too much time here. So just know it's written in Zig. The native bits are truly native, and we've written a lot of our own dependencies, such as an event loop. We'll go into it. Okay, so we covered the why a terminal. I hope that's compelling. I hope people are like nodding like, okay, I guess we could add the 197th terminal. I just made that number up, but some large number of terminals. But why did I choose Zig to write this in? It's pretty simple. I mean, I'll talk. I'll give it more detail. I'm going to show some cool things, but at a very basic level, I like the Zig community, I like the Zig language, and I like the Zig build system. All of these things put together make it a really fun environment and technically a really great tool to build a terminal emulator in. I think I have to use some sort of low level language with something like terminal emulators. You're interacting a lot with the sort of system level, and I care about performance with a project like this, and so being able to really strictly manage allocations and strictly sort of understand what is going on is really important. So I thought it was a great fit for the project. Why not some other language? I don't really want to see this question. If I see this question, I probably won't answer it. You can speculate all you want. It's nothing against any other languages. I just think Zig's a really good fit for this, and I enjoyed it. So that is what it is. Okay, so before we dive into some actual code samples, here's like the 10,000 foot view over what Ghosty's implementation looks like, broken down into a set of subsystems that implement it. So there's more little things, but this is sort of like the big parts of it. So the first one is something we call AppRT, which stands short for App Runtime. This is the thing that's responsible for windowing, OS input, mouse, keyboard, whether you're focused, unfocused, getting information about the hardware, such as monitor DPI, screen resolution, things like that. This is sort of the layer that makes Ghostty work across different operating systems at a user interface level. So it's implementations of this. I get into implementations another time, so you'll see this. There's the font subsystem, which is humongous. Font rendering is extremely complicated in general. So this is actually a significant amount of Zig here. So this font subsystem deals with discovery. I could do a whole talk on fonts, but just really quickly, discovery is the process of what do you know what the default font is? How do you find the default monospace font? If someone says their font is Fire code, how do you look that up on your operating system? How do you know the features of a font? How do you actually control the variable font axes? That's sort of all part of discovery. Or the other part of discovery is, say someone puts in an emoji and that Unicode code point, the Unicode code point isn't available in your font. How do I find a font that actually supports this single Unicode code point? That's a discovery problem. Rasterization is the process of blitting a single character. So if you're looking at this this slide, look at the R in rasterization. The process of painting that R is rasterization. There's shaping. This is ligatures most famously, but also multi-code point emojis, also Arabic languages, things like that. Shaping. Sprites. So there's a big part of terminals that are sprite-based characters. So you might have seen like box shapes and different things like that. We actually draw that at runtime. So we could draw them perfectly for the grid size. So those are all dynamically drawn at runtime. And then there's an atlas, which is I won't get into. Then there's the render subsystem. At a very basic level, it just converts terminal state to pixels. The render subsystem is completely agnostic to whether there's actually a GPU or not. Ghostty does use GPU rendering, but in theory, someone could write a CPU renderer. It would work fine. That's the rendering subsystem. Term.io, obviously short for terminal IO, manages the actual PTY, the subprocess, the input-output read-write of bytes to the running process. And then there's a terminal subsystem, which is all the terminal emulation core. This is everything here is Zig, but this is very heavily unit tested, really pure, side effect free sort of Zig code that emulates terminals and all those features. And then there's something that doesn't really have a name. I just put core here, but doesn't really have a name. But it's really the glue to glue all this together. And the main thing there is this abstraction called a surface. A surface in Ghostty is anything that is a terminal. And the reason it's called a surface is because Ghostty core does not care if that's a tab, a split, a window. In theory, it doesn't care if it's some VR thing painted across a wall. Like, it doesn't matter. It just glues together the fact that there's OS input coming from AppRT, font rendering, a renderer, IO with some subprocess, and terminal emulation, glues it all together and actually makes a terminal work. Here's sort of a more graphical approach to this. It's the same thing that I said, but really quickly going top to bottom. At the top, the app is launched. There's an OS, there's a keyboard, mouse, blah, blah, blah. All of this information goes into the app runtime. The app runtime manages a set of surfaces. Like I said, these surfaces could be tabs, splits, windows, anything, but all Zig core sees is a bunch of surfaces. And then per surface in this dash line, we have 2 threads. We have an IO thread managing the terminal IO and terminal state. And then we have a renderer thread that manages the font stack and the actual pixel drawing, whatever that might end up being. Okay, so that's a bunch of stuff about Ghostty. I'm gonna now, like, as excited as I am about the terminal emulator and stuff, this is Zig showtime. So I did want to focus more of this talk to being about Zig. So these aren't in any particular order, but what I want to do is show the Zig patterns that I use in Ghostty that I think made it a really compelling language choice. And I think for this one, I will have code on slides, but I'll probably drag Ghostty over and actually show you its source code and show you these things in the real, so that you can see what's going on. Okay, pattern number 1, comp time interfaces. Let's see. I'll also say that for any advanced Zig users in the chat here, I don't think there's anything novel here, but you'll hopefully, I think you'll like these as well. Okay, comp time interfaces. Okay, a comp time interface is a value with an implementation that changes depending on some compile time known information. Zig doesn't have any formal interface type similar to Go or traits in Rust or things like that. So this isn't a sort of interface in that sense. It's just practically an interface in the sense that it's static dispatch to some changing implementation chosen at compile time. The source code here are real examples. I'm going to go to it in Ghostty, but this is how we do a ton of stuff in Ghostty, from renderer choice to font implementation to what else? Terminal IO, all sorts of stuff. So I will talk about this because this is a really brief example, but the top shows how we're switching the font face implementation on Linux. It's free type. It could also be free type on Mac optionally, but on Linux it's free type. On Mac it's Cortex, and we also have a WASM implementation that actually uses Canvas, and so a web WASM implementation. So this shows a font face implementation changing, and you can see the use below where we're maybe setting the size, maybe checking if a font face has a certain code point, but the implementation actually changes. So let me actually tab over. I think you could see this. This is actually Ghostty running, obviously. Of course, I'm going to show all these code samples in Ghostty itself. But if we actually look here, you can see this is, I'm not lying, that this is actually how we do font face stuff. And if we go to like an implementation, like let's go to Cortex, it's just a struct, like I said, Zig doesn't have any sort of interface thing. So it's just a struct. The compiler will catch if any of the types or the function signatures or so on don't match. But we're able to use totally different internal state. So for Cortex, we have Mac OS font handles and sort of those sorts of things. And otherwise, it's just the same. We actually just have various functions that are expected to be called, and they're just switched at compile time. And then when you actually use the face, you just import this face const, and you don't really care what the implementation is like. So that's a comp time interface. Let's go back over here. They're a critical tool for cross-platform because we're able to change the implementation without any runtime overhead. And let's see. Oh yeah, they're also really useful for testing difficult components. Runtime dispatch is fine here, but um, in tests for test builds, we actually switch some interfaces around at comp time so that we can actually test things like terminal I/O without actually doing I/O. Right? It's a form of dependency injection basically, and it's particularly good for features that never ever vary at runtime. Obviously, if they vary at runtime, you'll have to do some sort of dynamic dispatch probably. Okay, one warning about comp time interfaces. A feature of the Zig compiler is that it only analyzes code that's actually referenced and used. It's a feature, not a bug, because it does enable a bunch of situational code to exist without nasty like C style if-def stuff. But the downside is that if you don't reference the code, you could have syntax, well, not syntax per se, the file has to parse, but you could have semantic errors. You could call functions that don't exist, things like that. And so for comp time interfaces, you just have to be really careful that if you have a CI environment or you're testing, you have to test every interface. You have to build every interface. So Ghostty does this through CI. We do all our builds in CI. This is that slide I showed earlier of the code architecture. And these are almost all comp time interfaces. So in this case, I've just changed it. So on the right, I should have changed the description, but on the right, oh no, we're going to switch over here, this slide. We now have the implementations, and these are the comp time interfaces. And then the third column, potential future implementations, and these are also, would be comp time implementations. So for AppRT, we have the embedded implementation. I'll show that later. GLFW, GTK. Fonts, we support font config, Cortex, FreeType, other stuff. Render, we have both a Metal and OpenGL renderer. And TermIO right now we just exec. But you can see on the right the future stuff we could actually do and will do in a lot of cases. Windows is a planned target for all this stuff. So AppRT font rendering is going to get a Windows native GUI system, direct write for fonts, direct 3D for the renderer. The web is also a future target via WASM. So we already support it with fonts, but app runtime needs to support it. The renderer could do WebGPU or WebGL, and so on. So there's a lot of sort of options here in terms of what you could do. Okay, pattern number 2, comp time data tables. And I use these a lot in Ghostty, and I think they're absolutely killer. So I'm going to go over beginner, medium, advanced. So here's a beginner example of a comp time data table. Let me just actually switch to the real thing. What am I showing here? This is probably Kitty. Perfect. Yeah, this is the actual file that I'm showing here. This is what I was showing on the same slide. It's an example of a table of data. You could see raw entries here is a table of data. You can see the type on the very top here is a tuple. I like using tuple for these raw formats because it makes the table below really, really clean. I do not like using tuples so much in real runtime use types because it makes it really, really complicated or unclear. So this example shows the sort of raw data for how to map certain keys to the Kitty keyboard protocol. This is something that there is no real logic to it. You just have to hard code this table into your program. There is a lot of this inside Ghostty. So this is Kitty here, but I also have, for example, let's see, keycodes.zig. This is actually a Chromium header converted to Zig, which has all of the key codes for USB, EVDEV, XKB, Windows, Mac, and the string code for all the keys. Again, no real pattern here, so you just have to hard code tables like this in your program. So yeah, this is sort of what it looks like. I'll go back to the Kitty example though. So yeah, I like using the tuple for the raw table because then you can just do one line, no field names, really, really short, really, really clean. But notice that neither of these are marked pub. The tuple and the tuple database is not meant to be actually used in the program. So then sort of the next thing that I do is process them. So here are there's a pub entry. Now we can see it's actually a struct with named fields. And then there's a list of entries. And these are all built at compile time. So we actually are using the raw entries and building these at compile time. And this one is not interesting because I'm literally taking the tuple and turning it into not a tuple, right? That's like kind of lame. But if you look at, let me open that Chromium file again. If you look at this one, the raw entries have all of these sort of key codes, Windows and Mac, and the same thing. If you're on Windows, you don't need the Mac key code. If you're on Mac, you don't need the Windows key code, right? So in this case, I actually take the entries and I only bring in the one that is important, the key code that is important for the target platform. So this helps limit the memory that your program might use because the Mac program does not have the Windows key codes at all in the compiled code. And so this is something that is pretty nice. Okay, let me see what else I can talk about here. Let's just switch back over. I will probably come back to that slide in a second, but just so you can see what I'm looking at. I showed you this. I just showed you this. Yes. Let's go back over here. So both of these were examples of tables that are really like, there's no pattern. So they're just like spit out, right? But there are tables with patterns. So here is another table that I use also for keyboard input. That is the escape sequence to send for various keys. There's a pattern to the specific key, but there's not a pattern for the whole keyboard. So you still need a data table that's sort of hard coded. But for the table itself, there is a pattern. So because this is comp time, this isn't a straight table. I've now written functions that are called at comp time that actually build the set. So, okay, here's the line 78 right here that I've highlighted for the up arrow key. If we're in the non-cursor key mode, which you don't need to know about, I call this PC style function to send this template of, escape bracket 1 semicolon, and then this whole here, and then capital A. And if we go to PC style, here's a function that's called at compile time that goes over all of the modifiers that are possible and actually builds the possible entries. So let me find the modifiers list so you can actually see. Oh yeah, here's a set of modifiers right here. So basically, each of these modifiers encodes to a separate number that fills that hole, and I'm able to do that at compile time using a function. This file is actually based on a file from Foot. And so if you were to look at this file in Foot, they don't have comp time. It's a C header. And so you would find a much longer file with a lot of duplication because particularly all of these things, there's at least 30 to 40 function calls here in this table section right here. You would see all of these fully expanded in that header file, which is noisy. So this is cool thing to do. It helps you not like fat finger things as well. All right. I will mention there's also, notice like the PC style, I wrap it in this comp time. It seems unnecessary because I'm only calling this at comp time, but by wrapping a function body in comp time, you could also ensure that the function is impossible to call at runtime. Since Zig has this cool thing that a lot of functions you could call at comp time or runtime, this is a way to just make sure that function is never ever called at runtime. Okay, comp time type generation. When Andrew ends up watching this, he's going to get scared at this slide. But I promise I'm going to put a lot of warnings on when you want to do this and when you don't want to do this. But it is a form of meta programming. First, a quick 30-second Zig tutorial on the built-in called type with a capital T. There's a built-in in Zig called type. It allows you to reify or create types out of thin air at comp time using comp time logic. So here's some really basic examples that I fit onto a slide. The top one, I'm creating a U32. The bottom one, I'm creating a 4-element array of U32s. And then in the bottom section, I'm actually using those types that I just reified out of thin air. You're able to construct any type, not the async types, but async currently isn't in Zig 0.11, so it's not as important, but you could basically construct any type using this function. You cannot construct construct declarations. So if you construct a struct or an enum or a union, you can't add functions to that type, but you can construct the actual type signature itself. Okay, so that's the 30-second quick tutorial. Also, fun fact, part of a very small, very small part of this, I actually implemented for the self-hosted Zig compiler. This is part of some of the contributions I made to the compiler. The feature already existed, I just helped port it. Okay, but beware, this is for Andrew, but this is also true. Beware, this is something you really want to limit the use of to situations where it just makes sense. You want to not go full meta programming. It really harms readability. It slows down compilation. It's a powerful tool, but it has a powerful cost. So be super careful. Okay, so where do I use this? Okay, let's take a look. Let's pop back over. Okay, so terminals have this thing. You'll see this is building on what we already talked about. There's a comp time element to this as well. Comp time table element to this as well. Let me close this so you could you're definitely looking at the right thing. So terminals have these things called modes. They're Boolean flags that can be set by a running program in a terminal, and they could turn on or turn off modes. So for example, here's one right here that I highlighted, mode 1000. They also all have numbers. So you would turn on mode 1000. If the program requests that, then what they're requesting is normal mouse events. Normal mouse events are just a form of encoding. If I remember correctly, it's just like left click, right click, maybe. Maybe it's all the buttons, I'm not sure, but normal mouse event. But for example, if you do mouse event any, you'll actually also just get real-time positional stuff. So as you move the mouse around, so I actually think Vim gets it. So as I'm moving the mouse around here in Vim right now, Ghostty is sending all the time sequences of where my mouse is, and yeah, but you have to subscribe to that. If you turn that on and you're not expecting it, you're just going to get a bunch of garbage in your shell, basically. So they have to be opted in, and those are modes. Okay, there's a lot of things you want to do with modes in a terminal. So the approach I took is to use some comp time mode generation, comp time type generation with a table to make this a little bit easier. So here you're seeing my table of all the modes that Ghostty knows about. There's many more modes. There's probably 100 or so, and Ghostty supports maybe 25 here. But these are the ones that kind of matter right now. But I could create this entry for a mode. Again, not pub. This isn't something that's used anywhere else in Ghostty. This is just data creation. And each mode has a name, which is a human-friendly sort of string. It has a value, which is a comp time int. This is the value that actually could be set in the protocol. And it has a default value of whether when the terminal launches, it starts out on or off. So for example, cursor visibility. When you start the terminal, we want the cursor to be visible. So on. Blinking actually false, but depending on your configuration, Ghosty's configuration actually defaults as the true, so it turns it on launch. But we do that. And this is about comp time type generation. So let's go find that. Here we go. Right here, line 100. We are creating the mode enum. So this is actually right here. Let me just highlight the whole thing. This is actually iterating over the entries, creating a bunch of enum fields, and then using that type built in to, at comp time, create an enum type with a U16 backing U16 that actually is all those fields, and it's using this name as the actual enum key name. So this lets me reference, I think I showed in the slide. Yeah, if you look at the very bottom part of this slide, I actually have a type called mode that I could just reference using normal enums, but that's dynamically generated from the, oh sorry, I realize I keep moving my camera. It's using the wrong camera, that's funny. But that's dynamically generated from the data table. There's other reasons sort of to create this data table, but that is a big one. And you can see in the structures that I end up like using with modes that I use this enum all over the place. So it's something I use quite a lot. Here is another one that I use. It's not an enum. This is actually, I create a packed struct. And in this case, It's a pack struct of all the settable modes because modes are Boolean flags of true or false. I actually am able to create a pack struct with all of the modes that I support in a single type, and let Zig deal with what that backing type is and just set bits in order for the modes. So that's useful as well. So there's a bunch of type stuff happening in this file. Okay. Okay, this is another form of comp time type generation. You could generate types that are dependent on other types. I want to be clear, I don't do this a lot in Ghostty. This is actually the only place I do it in Ghostty, and all of the type generation I do, I think, is shown in this slide. So as large of a project as this already is, I think I only do this 2 or 3 times. But the important thing is the 2 or 3 times I do it really, really helps, like really lowers the amount of glue code I would need or helps the runtime cost because I could do so much upfront at comp time. So it's rare. It should be rare. It is rare, but these are good examples. So here's where I generate a type based on other types. This shows the creation of the font index structure. I'm just going to use this slide. I won't go over to it in the real code because this is exactly what it is. The font index structure is a pack struct backed by a single byte, and it is a byte that could represent any style and font face that Ghostty currently knows about. And so is it regular and is it fire code, whatever? We could represent that in a single byte. But the way we do that is it's dependent on the number of styles we support. So what we're sort of doing here, we could determine the exact number of bits that we're allowed to have for the index by first, okay, I'll go first line here, const tag type. We're getting the backing tag, backing type for the enum of styles. Actually, I will go over here because this is going to be way easier to see. Okay, here's the actual code. It exists. It pretty much looks the same. I'll do here style equals, where's style? Okay, so here's the set of styles that are supported by Ghostty. You can have regular, bold, italic, and bold italic, showing you it on the right. Okay, so obviously that's a 3-bit sized enum. What I could do here is I could actually get the style tag type, get the number of bits that it needs, and I could do 8 minus those number of bits, and those are the amount of bits I have available for an index if I want it to fit in an 8-bit type, a byte. Then I could create the index and actually default it to 0. So as I add more styles, that'll limit the number of font faces we could support in general at runtime, all loaded at once. Right now, we could support 5 per style, which in practice has never been an issue yet. That's only, 32 font faces. You might be wondering, why would you ever even have 32 font faces? But you have to remember that fonts only support certain code points. So if you, for example, run a program and it outputs, let's say, Asian characters, we probably have to find another font for you to satisfy those Asian characters. So you'll actually end up over the course of running a terminal for a long period of time, on average, having around 2 or 3 fonts per style. But 2 or 3 is much less than 32. If you have 32, something really, really special is happening. And what we end up doing in that case is we just render the Unicode replacement character, the question mark, if we run out of memory to fit more fonts. But the point is, I'm able to pack all of the sort of pointer or the index to a specific font. I could pack the style and the index directly into a single byte, and it helps to be able to do this comp time stuff to do that. Okay, moving away from that, I think this is actually the last pattern. There might be one more, but Swift and Zig. This is sort of unique. This is a generalized pattern to any language that could call a C API, not just Swift. I'm just using Swift because that's what I use in this project. But this is a pattern. This isn't just a specific Swift and Zig thing. The pattern is any language that could call C API plus Zig. Okay, the problem I had was that modern macOS development effectively requires Swift. Yes, you could use Objective-C, and Objective-C actually has a C API to its runtime. So in theory, you could use pure Zig calling the Objective-C runtime API to write a native Mac application. That is how Ghostty started. I understand it pretty well. The problem is all the new fancy features that Apple is shipping, they're probably shipping at the event right now, are shipping as Swift-only frameworks. And so that makes it impossible to make a native application that really feels modern because you can't use the modern features of the operating system without writing Swift. That's the problem. Okay, so taking a look at that problem, I thought, okay, Zig could call C. Swift cannot export a C API from the standpoint of a Mac application, but Swift can call C, and Zig can export a C API. So these last 2 points made me think, okay, I think I could export a C API and just have Swift call it from Zig, and that way keep most of my things as Zig. And I'll show you that in a second. I'll note here that on Linux, I don't have this problem because I use GTK. GTK is a C API. Zig's ability to call C APIs is super well known. So on Linux, it's pure Zig end to end. But the problem is on Mac with Swift. So here's what I actually ended up doing. I actually ended up building an alternate artifact for Ghostty in that it could actually compile as a C library, and it's pretty Mac specific right now, but it is a C library, and so I actually write. I'll show you it to you. I'll show you the header file. Here is the Ghostty header file. This is our C API. We could go down here. You can see there's a lot of functions for this, but this is the C API that Swift calls in order to do everything with Ghostty, which is pretty cool. So what I ended up doing was I ended up building, let's go back over here. I ended up building this as a static library. You can see the build style down below. Slightly more complicated than this. I made it shorter for the presentation, but I also generate both x86, 64, and AArch64, and also LiPo them together. And then I also bring in all the dependencies and create one giant fat static library to make things easy for Swift. But generally speaking, I'm creating a static library here. And then from Swift, it looks like this. I mean, you can import C in Swift. It's nothing magic here, nothing crazy. So I'm able to just import it and call it, which is pretty cool. And the actual API, if you look, the only Mac specific API here, if we could find it, when you're creating a surface, again, a surface is anything with a terminal. So it could be a tab split, anything. But when you're creating a surface, you pass this struct back into the Ghostty core. The only Mac specific thing in this entire thing right now is that I require a I require a pointer to the NS view underlying the whole thing. And so this is the app. I'm in the app. So this square rectangle where you see Ghostty is the view. And then in Zig core, in Zig, pure Zig, I take that view, turn it into a metal view, and then start sending GPU instructions to draw onto that view. So it's pretty cool. But that's the only Mac specific thing in this right now. So yep, Swift and Zig. Linux, Zig owns main, compiles an executable. On Mac, Swift owns main and compiles a static lib. There is over 90% code sharing, even omitting the GTK stuff. Like 90% of all of Ghostty is totally cross-platform stuff. The last 10% is either Linux-specific GTK or Mac-specific Swift. But sort of what's extra cool is the flexibility that this gives in the future. So the future is I actually plan on shipping libghosty as an embeddable library. And the idea is that anybody can embed libghosty, point it to, on Mac, a view. On Linux, it could be a frame buffer, it could be other sorts of GTK specific items, and just get a fully functional, fully featured terminal anywhere that's highly performant. And you could really drop this pretty much anywhere as long as we have all those sort of subsystems with their comp time interfaces and everything all supported. So this is something that is not just a theory. I mean, this is literally how the Mac app works. So it's very possible and something I want to do. Okay, so that was a tour of the major patterns we use. There's a lot more. I think that's good for one talk. Some of those patterns could probably be whole talks on their own. I could give a whole talk about font rendering, a whole talk around the Swift stuff, a whole talk around terminal security. There's so many things here. But I just want to finish the talk by talking a little bit more about Ghostty, the project, and then open it up for questions. So what's next for the project here? The terminal emulation itself is reasonably complete. I've been using this terminal full-time since April of 2022, so almost over a year. And for me personally, it works great. I developed Ghostty in Ghostty. It's the only terminal I've used. All the not demos, but all the code samples I showed today, like I've just been tabbing over to Ghostty itself. Like this is the actual program, so it obviously works and isn't any sort of fake software. But as I've added testers, they've also been using it full time, and we've just been building out the feature set. The focus is really currently on the native platform experiences. We have almost no sort of misrenderings and terminal state bugs anymore. There's one that's hiding that no one can figure out how to reproduce, and it's quite rare. But because of that, we sort of moved upstack. We're focusing on things like setting GUIs and search GUIs and cosmetic things like that. Like yesterday, I'll tab back over here. Let me just open a new split. Go to a faster thing. So yesterday, for example, we implemented this where splits, fade out the non-active split. Those are the types of features and improvements we're making right now. Pretty like not core terminal stuff. There's also a lot of work to do around infrastructure, so documentation, websites, stuff like that. There is still a lot of room for improvement. Also, I will say there's a ton of room for low-hanging performance wins. And this makes me really excited because, like I said, Ghostty is already in the category of fast. But there's a lot of stuff that I see that could be done to improve the performance. I want to fuzz the VT stream. Some community members have already started helping with that in various ways, and we found some bugs, found some crashers, and so that is something I definitely want to do. There's a bunch of performance-related paths that are completely unmeasured, so we haven't tried to optimize startup time other than non-pessimization. We haven't measured latency, etc. So there's certainly room for improvement there. And I would say the weakest point in terms of Ghosty's performance right now is its memory usage. Its memory usage is not in a super acceptable state. There are some really easy wins here. Like, for example, the scroll back right now is not allocated on demand. Every terminal you creates a full scroll back buffer in memory, which is horribly overkill in a lot of cases. So little things like that exist, and I'm not worried about it. But it is something that someone needs to pay attention to. I took the approach that a lot of modern computers have a lot of memory, so that's a lower priority to me than rendering performance and CPU performance, which have gotten a lot of attention that I think Ghostty already does pretty well at. So memory, we need to look at. As for the beta program, I want more beta testers. So if you're interested, please join the Discord. The general process that I follow is I invite about 5 people. I fix all of their issues. And when there's a few days where there's no real issues that show up, I invite 5 more people. The past couple weeks have been quieter than normal because of the baby, but I am about to start this process all over again. So there's no real timeline on waves. Like if you join the Discord, there's no timeline of when you'll get in. It's just when the previous wave is ready. That's about it. If you do have Zig experience, or you have macro GTK development experience, or terminal experience, if you maintain a terminal UI app, if you're a contributor or maintainer to things like Vim or Helix or Zellige or Tmux, something like that, if you're one of those types of people, I'll get you in right away. But otherwise, I do this 5 tester wave thing. And then obviously Ghostly 1.0 when. This is funny. This is I did this before the baby was born, but the plan is next year. The first version will be a 1.0, and it's going to be very feature complete. Terminals are sort of this weird sort of thing, in my opinion, where they're a little bit binary of whether they work or don't work. Like if you get a terminal and it crashes or it misrenders something, then the terminal just doesn't work for you. Like if you're doing real work, you have to use a terminal that always works for you. And so I've been pretty careful because the first version that comes out just has to work. And so the first version will be a 1.0. And like I said, the license will be GPL, most likely. And I've had a baby, so this is now past tense. And that's it. So thank you very much. And I think I have
One second, Mitchell. I think we got disconnected from Twitch again.
okay.
What's funny is that, well, this happened at, I guess, the perfect moment. So, okay, let's transition view.
Yeah.
I think we should be back. Chat, can you confirm that we're back? What a timing. Oh, I see ghosts in chat. Yep, you're back. Yeah, thank you. Twitch is like this today, I guess. Okay, so first of all, in order, thank you very much, Mitchell. That was an awesome talk. Second of all, chat, please say thank you to Mitchell. Spam a little bit, make him feel welcome and appreciated. So yeah, claps in chat. So now we have room for questions. So after the wave of thank yous is done, please type up your questions. Maybe preface it with Q colon, if you don't mind, so that makes it easier for me to spot them up. And while we wait for people to come up with questions, I want to start, Mitchell, with one question of my own. So
Sure.
you have experience, well, you have extensive experience with like big scale, let's say enterprise level software development. And now you also have experience with like a non-trivial Zig project and Ghostty. So I was curious about your opinion on Zig when it comes to like, I've heard people say that Zig shines in smaller projects, but people are not so sure about like large scale projects. Do you have an opinion on that?
Yeah, I have some experience here. For people who don't know, I mean, I started a company that, from an engineering perspective, grew to hundreds of people, maintaining dozens of projects, and yeah, it was all Go, mostly Go, I would say, in that environment. Um, and I learned a lot in that environment. And what I like to say is, you mentioned like big projects, and when people say big, I like to say, what do you mean, like big technically, or big from a human perspective? Like, are there a lot of people working on the project, or is the project technically big? And it could be both. But I think from a technical standpoint, um, I could say Ghosty is quite a large project. It's big, technically big, and I think Zig has been great. I've had no issues whatsoever with the project. I think Zig's been a great fit. Nothing really to add there, just yes. From a human perspective, I have less experience with Zig, right? Ghosty is a small project. So I don't know, but if I look at why I liked Go so much as a choice at my company and working with people, it's because it's a simple language. It's simple to teach, and it's also simple to read. And I do think Zig has a lot of those qualities for the level it's at in the stack. For a lower level systems language, it's it's relatively syntax light, and it reads top to bottom. So I'm not going to pick on any other languages, but my opinion, the reason I personally, this is my opinion, so don't extract this any further. But the reason I personally don't like working too much in Rust, I have written Rust. I think as a technology, it's a great language. It has great merits. But the reason I personally don't like writing Rust is every project that I read with Rust ends up basically being chase the trait implementation around. It's like, what file is this trait defined? What file is the implementation is? How many implementations are there? And I feel like I'm just chasing the traits. And I don't find that particularly, I don't know, productive, guess I should say.
Mhm.
I like languages that you start on line 1, you read to line 10, and that's exactly what happened. And so I think Zig's a good fit. And I think Andrew and the core team is doing a really good job of balancing that. So I'm really excited about it.
Awesome, thank you. So in the meantime, I've seen a few questions. I also saved one from earlier. So this one is from while you were still explaining stuff, but I believe you didn't touch upon it too much.
Okay.
So the question is, why write the font stuff from scratch? This sounds like it's doing a lot for fonts that is probably useful for a lot of other stuff, application games. So it could be its own project at some point.
Yeah, the font stuff in Ghosty is 99% agnostic to terminals itself. So yeah, I think especially once it's open source, I super welcome anybody to learn and grab from it. Um, I didn't write it from scratch irrationally. I use free type underneath for rasterization. I use harfbuzz for shaping. I use libraries like that where I can, but everything above sort of had to be re-implemented because honestly, definitely in Zig, but even in C, there's very few projects that do this. And so I couldn't find any library that I could adopt to do this. There is a smaller reason, which is that I can optimize it for terminals. I would say the optimizations are not super important, but there are small wins. And so I think owning those dependencies helps a lot. But I do think I know for sure I would never write one from scratch again. It's the saddest I ever am is when I'm working with fonts. It is an exercise in true despair. But if I ever write another project that needs font rendering, I'm certainly going to steal Ghosty's font rendering.
Good to know. Good to know. um, so, what does the Linux executable look like? Is it dynamic or static?
It's both. So for debug versions and for I think a lot of the versions that people are and the testers are compiling from source, they're static. But I in CI I test dynamic builds on every commit because official system packages when we official OS packages when we get there by guideline are going to have to be dynamically linked, and so that's very important to me. So you could do both.
Cool. So I guess that means for the Z people who love static linking that we're gonna have to fetch our own copies of Ghosty instead of downloading it from the package manager.
Yeah, the only thing that's not statically linked are the things that can't be. So GTK libraries, X11, OpenGL drivers, stuff like that. But everything, yeah, the typical Zig from scratch compiled binary, everything else is statically linked.
Cool. So let's see. Is Windows support planned for 1.0 or in a later release?
We'll see. Windows is super important to me. There's a couple major features that are standing in the way of me even looking at it right now. I would love for it to be part of 1.0, but I'm not committing myself to that. One of the big issues is I use Linux and Mac very regularly, both of those very regularly. So I understand the systems. I have a lot of experience with both, and so I could do really well. I am really, really naive when it comes to Windows and its tech stack and idiomatic patterns and things like that. And so I'm a lot more afraid to dive into the Windows world, but I'm hoping there are a couple people in the community that already are Windows plus Linux users, and I'm hoping that the community can help. Just in terms of knowledge, I'm really happy to do the work. Just in terms of knowledge of how I should do it. So we'll see, but it's planned for sure, just not sure when.
That's awesome. Also, I never dared to port Bork to Windows, so I guess the day you do it, that's the day I have to do it. Although I think in my case it's going to be dramatically easier, but that said. Awesome. Let's see more questions. Can you share a little how packaging Ghosty works on macOS, like making a dot app, signing, etc.?
Yeah, I think I could do this pretty quickly.
Let's go.
Close this. So in the build.zig, okay, so you could see I have a bunch of stuff here that I create the static library, I run a lipo, I create universal binaries. I actually create an XC framework. I do all that in build.zig. So the final artifact for Mac on build.zig is an XC framework file. And then if I go to okay, if I go to, this is my GitHub action that actually builds it. I use Xcode build to build it. The reason I use Xcode build is because it's simple for the native app. It handles signing for me, things like that. But then I also do additional code signing. I do notarization, and then I upload the fully notarized binary to the releases folder. So it's plumbing. It's a lot of work. Like Zig doesn't automate that for you, but it is all signed and notarized binaries for macOS.
Nice. I think that Jacob has been working on some insane re-implementation of the Apple toolchain to be, completely self-sufficient. Although,
I think that'll be good. That'll be good for normal Zig apps, but
yeah.
my like little Swift amalgamation, like it's not gonna help.
Mm-hmm.
Cool work though.
So
Yeah.
I have two more questions, and then you're free to go. So,
Okay.
second to last one is about the license. So, will libghosty also be GPL licensed or more permissively? Which is a great question considering that libghosty is a lib.
Yes. And I see who asked that question, and you're in the beta. So I would I would love for you to discuss this with me in the beta testers channel. I think one of the considerations that I'd like to make is dual licensing
Mhm.
the project specifically for the library. I think that yeah, the libghosty being GPL will be very difficult. One of my like audacious goals that I've never talked to any of these maintainers about. So this is just a personal like can it be done sort of goals is that I would love for the WASM build in particular to replace the terminal in Visual Studio Code. Um, Visual Studio Code's terminal is probably one of the most widespread terminal emulators in the world. And I think that would be a really big win. It's also very slow, like very slow. People complain to me all the time about the Visual Studio Code terminal. So that's MIT licensed. The Visual Studio Code's MIT licensed. They can't bring in a GPL dependency in there. So that is something I'm super interested in. So if you know a lot about open source licensing, I don't have a ton of experience with GPL. I don't have a ton of experience with dual licensing. So if you are one of those people, then I'd love to have you as part of the project in order to just talk through how we could do this in a way that keeps the project free and open source and allows for permissive usage without um, yeah, people taking advantage of the project. And the reason I'm looking at GPL to begin with is because there are some venture-backed terminals and other things out there that embed terminals, and I don't want them to necessarily have a free lunch when it comes to the work that we're doing with the terminal. So we are trying to figure out a way to do it. Yeah.
I see. I mean, wouldn't you love for them to take your stuff, split the community in half, like add proprietary extensions, whatnot, turn off features that you added?
I don't know. I don't know. I don't think so, but I'm willing to talk about it. I mean, we have time up until the 1.0.
I see. No, that's a fair point. I can totally see both sides of the argument, right? A license that it's too restrictive, it's a problem. I think your point about VS Code
Yeah.
is amazing because if that were to happen and like you would generally make development, like worldwide development, more effective, more efficient. Like you would
I
probably
hope
say,
so. I don't, and I
yeah,
don't,
yeah,
and I don't need like I've said this before in another talk I gave about Ghosty. Like I don't need Ghosty to like have world domination or anything like that. I think the impact that I'd like Ghosty to have is to be able that future slide that I said where I'd like to be able to move text application development forward. If other terminals implement that, then that's the win that I'm looking for. I
nice.
don't need it to be the Ghosty code itself, but I think like the best way to push it forward is to do everything you can. So that's why I'm looking at it. Yeah.
Makes sense. Okay, final question. This one is from Andrew. He popped in chat to ask you. So, I heard you had a baby. What is your strategy for work-life balance?
I'm still learning. The baby's only 7 days, 8 days old. Right now, I'm a first time parent. Right now, the baby eats every 3 hours, and I'm up every 3 hours and helping feed the baby. But we're the reason I chose for this talk to start at 11 is because the baby eats at 10, the baby eats at 1. And so I'm slotting it right in. So basically, what I've been doing so far is working in between those slots where it makes sense, and yeah, it's been all right so far actually. And then at night, we have some family help and stuff like that. So at night, I have a little bit more time, and I never was a night programmer, which I know is odd. A lot of programmers are night people. I was always like a wake up at 7 and work until like 4 type of person, and then I would just like be off. But now I'm kind of switching where my mornings are almost completely filled with a baby, and my late afternoons and evenings are more of my programming.
Cool. Okay, so that was it. I've seen that there were a couple more questions in chat about other technical details of Ghostty. I would say to everybody who still has questions, join the Ghostty Discord server and go make friends in the Ghostty community, which might coincidentally also get you picked as a beta tester. So, Mitchell, thank you very much. That was awesome. Is there any final words before we end the show?
No, just want to thank everyone. And the questions are great. The comments were great. I'm excited about this project and hope to see you in Discord and hope to build a nice, fun community around it.
Awesome. Thank you very much. So, bye-bye, Mitchell, and let's end the show.
Yeah.
So, thank you, everybody, for being here to the first episode of the new season of the Showtime. The show doesn't have a fixed schedule. The more talk applications I get, the more speakers I have, the more often the show will run. So if anybody here attending is interested in giving a talk, please do send me an application. And with that, see you next time. Bye-bye.
This is how we